Okay, so let's find the Laplace transform of this piecewise defined function. And we're going to use the integral definition of the Laplace transform to do so. So that's the integral again from 0 to infinity of f of t e to negative st dt. So you'll notice this time that our integral is going to have to break into two pieces because our piecewise defined function has two different pieces. So for the first part, it's integral from 0 to 2 of the 3 e to negative st dt plus the integral from 2 now to infinity of e to the t e to negative st dt. So again, we've got the integral of 3, 0 to 2, e and negative st dt. And then for the other integral, well, we can actually combine those exponentials together. So integral from 2 to infinity of e to the 1 minus st dt. And then a quick substitution, we've got negative 3 over s, e to the negative st, note from 0 to 2, plus 1 over 1 minus s, e to the 1 minus s times t, from 2 to infinity. All right, and then from there, we can now evaluate this. So that's going to be negative 3 over s, e to negative 2s, minus negative 3 over s, e to negative s times 0. Back here, this is a limit. Limit as capital T goes to infinity of e to the 1 minus s times capital T divided by 1 minus s. And then minus 1 over 1 minus s e to the 1 minus s times 2. So we clean this up a little bit. We're going to have a negative 3 over s e to negative 2s plus just plain 3 over s. And then we're going to have a minus or a plus if you want to change the order around 1 over s minus 1 e to the 2 times 1 minus s. And again, we could change the order of that subtraction in the exponent. But that's a pretty good way to leave that right there. But again, that's a 1 minus s. It becomes fun doing this sometimes. Try that again. 1 minus s. So we'll actually box this. Is kind of messy. But that right there is our Laplace transform of that piecewise defined function.